Welcome to the 7th session on galvanic cells. In this cells, we are going to see a type of cells. It is electrolyte concentration cells, but they are electrolyte concentration cells without transference, because we know that the transference of matter from one half cell to the other half cell occurs due to change in concentration. Okay, the electrodes are similar. Now, when these electrolytes are kept in contact, direct contact, there is a chance of transference from one electrode to another due to the concentration difference. Now, here we are going to consider the concentration cells in which these electrolytes are not in direct contact, but they are in indirect way connected with each other, so that there is a flow of electricity. Now, this type of cells are concentration cells without transference. Now, let us see about that. That is, electrolyte concentration cells are cells in which the electrolytes of the two half cells are at different concentrations and they are in contact with the same electrode material. So, electrolytes are of different concentrations, but the electrodes are of the same material. Okay. Such type of cells are known as electrolyte concentration cells or electrolytic concentration cells. Now, these cells are further classified into two, that is, electrolyte concentration cells without transference and electrolyte concentration cells with transference. So, from this we can just imagine, like if it is without transference, these solutions are not in direct contact, and whenever there is a cell with transference, these electrolyte solutions are in direct contact. Okay. Now, what do you call an electrolyte concentration cell without transference? This is the one in which the electrolyte solutions are not in direct contact. Now, how are they connected? In an indirect way, that is through a salt bridge. Okay. So, during the working of the cell, there is no direct transfer of electrolyte from one solution to another. There is no direct transfer. Okay. So, such electrolyte concentration cells or electrolytic concentration cells are known as electrolytic concentration cells without transference. So, let us see in detail. Here we have electrolyte concentration cells without transference, where the electrodes are reversible with respect to cations. So, we have two types here, that is, we have a cell in which the electrodes are reversible with respect to cations, as well as electrodes which are reversible with respect to anions. Okay. So, one of the example is that hydrogen gas in contact with HCl solution. Here, if you note, the pressure of hydrogen gas is here in the anodic compartment, this is anodic compartment, and this is a cathodic compartment. It is 1 bar. On the other side, again we have the same hydrogen gas at the same pressure. So, the electrode material in both cases, they have got the same concentration. Now, when we come to the electrolyte, see, this hydrogen is contact with an HCl solution where its activity is A1, while in the cathodic compartment, the activity of HCl is A2. So, the concentration of the electrolytes are different, and therefore, they are known as electrolyte concentration cells. Okay. Now, let us see what is the anodic reaction. Here we have anode, means you have the oxidation. So, I take hydrogen gas 1 bar, giving H plus ion plus electron, but this H plus will be of activity A1. Okay, because that is in the anodic compartment. Once the hydrogen gas goes into solution as H plus ions, its concentration will be A1. Now, in the cathodic compartment, it will be the reduction. So, that is H plus will take up electrons and get converted into half hydrogen gas. Okay. and the pressure is same as 1 bar. Okay. But here the hydrogen ions are getting reduced at the cathodic compartment where the activity of H plus is A2. See, that is different. So, here H plus ions produced by oxidation of hydrogen gases with A1 and the other case, that is A2. Now, I will give the overall reaction, that is, you can have cancel these two because they are hydrogen gas at the same pressure and the electrons are cancelled, and we get the expression as hydrogen ions at A2 activity getting transferred to hydrogen ions of activity A1. That is, hydrogen ions are moving from cathodic compartment to anodic compartment. That is what is occurring here. Okay, again transference of matter, this is from cathode to anode, that is H plus ions, and therefore, this is again a concentration cell. Here the value of N is equal to 1, E naught of cell is equal to 0. So, the EWOT stands for without transference, that is what I give it as WOT. EWOT is equal to minus 2.303 RT by F, where N is equal to 1 log concentration of products, that is A1 by A2, that is reactants. Removing the minus sign, that is, we are just reversing this fraction, you get 2.303 RT by F log A2 by A1. Here, you should note that for EMF to be positive, that is, if the galvanic cell has to give an EMF, A2 should be greater than A1, that is, numerator should be greater than A1, only then this will be positive and you will get the EMF positive. Okay. Now, here I would like to make clear one point, that is the anode and the cathode reactions. Last time I was saying that it was 2 because I had taken hydrogen gas as such, not half H2. Now, let us see whether there is any change if I change the reaction for the Nernst equation. I would like to make sure that even though we change the number of moles, provided there is a balanced equation, the Nernst equation will be as same as we have written above. Because this case I have been taking half H2. If you remember, see half H2 giving H plus. Okay. Instead of that, if I am putting it as hydrogen gas, pressure 1 bar, okay, will give you 2 H plus ions of activity 1, that is in the anodic compartment, plus 2 electrons. Now, in this case, the value of N will be 2, that is what the confusion will be. Next is the cathode. At the cathode, we know that cathode the activity is 2. So, the H plus ions of activity 2 takes up 2, again I will put it as 2 H plus because it is here 2 H plus. 2 H plus of activity 2 takes up 2 electrons, giving hydrogen gas, again that is 1 bar. Okay. If in this case you might be imagining that the value of N will be 2 and you will be getting it 2 over here. Now, let us see what is the overall cell reaction. That is hydrogen gases, they get cancelled, 2 electrons get cancelled, and here we will be having 2 H plus of activity 2 getting converted into 2 H plus of activity 1. Now, again I am not going into the details, I will just put it as N is equal to 2 and E naught of cell, of course, that is equal to 0 volts. Now, the Nernst equation E will be equal to, without a transference, will be equal to minus 2.303 RT by, instead of N is equal to 1, we will be getting as 2F log concentration, that is A1, concentration of H plus ions, that is A1, 2 moles you will have square, whole divided by A2 whole square. Okay. So, this square goes to the power, that is equal to minus of 2 into 2.303 RT by 2F log A1 by A2, right. This 2 and 2 will get cancelled, and finally, you will get the same expression. Remember, this is the same expression as we got it is here, that is minus 2.303 RT by F log A1 by A2. So, it is immaterial whether we are taking in terms of 2 hydrogen ions and hydrogen gas instead of half H2 and a single hydrogen ion gas. When we come to the Nernst equation, the Nernst equation will be the same. Okay. Now, let us move on to the general form. EMF of the cell without transference in a concentration cell is equal to 2.303 RT by NF log A2 by A1. That is, A2 is the concentration in the cathodic compartment and A1 is that in the anodic compartment. So, anodic compartment, instead of that, in the other case we were seeing it as in terms of anodic compartment divided by cathodic compartment, and here it is activity of cathodic compartment divided by activity of that electrolyte in the anodic compartment. So, these are of that of the electrolytes. Okay. Now, one more point I would like to mention here is, that is, here we have only one of the ions involved, though we are taking the HCl solution. See, here we have been taking HCl as electrolyte, while in the Nernst equation there is an involvement of activity of H plus ions only. This is a point to be noted. Okay. So, here this is of H plus ions alone, one of the ions, again that is for hydrogen, or one ion, one type of ion, that is here in this case this is the cathodic ions, sorry, cations. Now, as we all know, activity of any substance is equal to activity coefficient into molality. Okay. Now, when I am going to substitute the activities in terms of molality, you have the activity coefficients multiplied by molality. Coefficients multiplied by molality. Now, this is the expression, we will get it as 2.303 RT by NF. Instead of activity 2, I will put it as gamma 2 M2, that is activity coefficient of that component 2 and that molality of that same substance divided by gamma 1 into M1. This is without transference. Now, what we are going to do is, if we are going to substitute the activities by mean ionic activities, that is A plus or A minus, that is we write it as A plus or minus, just because for if I take an electrolyte, for example HCl, I have H plus ions and Cl minus, you cannot determine the activity of H plus alone or the Cl minus alone. So, what we do is, we take the activity of HCl and we take the mean of it and consider that to be activity of H plus and Cl minus. So, this is mean ionic activity. Okay, mean means average. Now, since we have only one of the ions, that is only H plus ions are involved. So, E without transference is equal to 2.303 RT by NF log, this is of H plus ions alone, that is activity, mean ionic activity of 2 divided by mean ionic activity of 1. It's a very important point because we will need it later. Okay. Now, let us go for another one, that is a metal in contact with metal ions. The anodic reaction, that is oxidation, zinc solid gives Zn2 plus and the activity is A1 plus 2 electrons, that is oxidation. In the cathodic compartment, what happens is Zn2 plus ions of activity 2 will get converted into Zn solid by taking up 2 electrons. Okay. So, one oxidation, the other one is reduction. Now, let us take the overall reaction. 2 electrons on both sides get cancelled, Zn solid on both sides get cancelled, and the final equation becomes Zn2 plus of activity 2 getting transferred into Zn2 plus of activity 1. This is a cell reaction. Now, please note the value of N is 2 and therefore, N is equal to E naught of cell is equal to 0, E without transference, EMF of the cell without transference, WOT is equal to minus 2.303 RT by NF divided by products by reactants. So, A1 divided by A2. Removing the negative sign, 2.303 RT by 2F, it will be log, instead of A1 by A2, this will be A2 by A1. Now, again for the EMF to be positive, A2 should be greater than A1. Okay. Now, in general, this is a case where we have taken N is equal to 2. Now, we are going for the general one, that is E without transference is equal to 2.303 RT by NF log A2 by A1. Now, activities are replaced by molalities multiplied by their activity coefficients, and you get E without transference as 2.303 RT by NF log gamma 2 M2 divided by gamma 1 M1. Now, again here we are going to replace their activities by mean ionic activities, and here also we have noted that in the final equation we have only one of the ions, that is only the zinc ions are involved, not its anion, only the cation zinc is involved, and therefore, this will be equal to 2.303 RT by NF log mean ionic activity 2 divided by mean ionic activity of 1. Now, we are going to consider the cell. These are with reversible with respect to cations, and next case we are going to consider the electrodes reversible with respect to anions. Now, here is an example for that, that is silver in contact with a paste of silver chloride, which is put in a solution of HCl of activity 1. This forms metal insoluble salt in contact with an electrolytic solution containing its anion of the salt. See, the anion is chloride, so we have HCl here. Okay, the activity is A1 and this forms the anode, and the cathode is again HCl activity 2 in contact with a paste of silver chloride and silver. Okay. Now, let us take the anode reaction. Anode reaction is the chloride ions will combine with silver ions, forming silver chloride solid, releasing its electrons, because silver, to form silver chloride, it has to remove one of its electrons and become silver chloride. So, this becomes releases an electron. So, that is an oxidation, and AgCl solid takes up electrons in the cathodic side. AgCl takes up electron and gets converted into silver, and chloride ions are being released. Okay. The net cell reaction will be, you can see that AgCl solid, you can cancel both electrons, Ag, and finally, the reaction will be chloride ions of activity 1, chloride ions of activity 1, that is in the anodic compartment, get transferred to chloride ions of activity 2, 1 to 2. Okay. Now, number of electrons n is equal to 1, E naught is equal to 0, and EMF without transference will be equal to minus 2.303 RT by F, because n is equal to 1, log products by reactants activity A2 by A1. Now, removing that negative sign and inverting this fraction, we have 2.303 RT by F log A1 by A2. Again, here again it to be positive, A1 should be greater than A2. Okay. In general terms, E without transference equal to 2.303 RT by NF log A1 by A2. Replacing that by a product of activity coefficient and molality, 2.303 RT by NF log gamma 1 M1 divided by gamma 2 M2. If the activities are replaced by mean ionic activities, it becomes mean ionic activity of 1 divided by mean ionic activity of 2. Just watch. In the other case, when it was cations, it was the reverse case. It is mean ionic activities of 2, that is in the cathodic compartment, divided by anodic compartment. In this case, it is a anodic compartment divided by cathodic compartment. This is because it is reversible with respect to anions. Okay. Now, let us move on to the problem. Here, we have a concentration cell consisting of 2 silver electrodes, one immersed in silver nitrate solution of concentration 1 molar and the other immersed in silver nitrate solution of 0.01 molar. The concentration of its ions at 298 Kelvin. So, the concentrations are mentioned at 298 Kelvin. The two solutions are connected through a salt bridge. So, they are not in direct contact. Now, calculate the EMF of the cell. Here, what are the things given? We know that it is a cation reversible cell because it is silver in contact with silver nitrate. Okay, here this is the cation, silver gets oxidized and silver gets reduced. So, this is a cation reverse with respect to cations, reversible with respect to cations. And the expression for this is without transference. We have seen that for anions it was 1 by 2, right? And here. And in the case of cations, if you have noted, it is 2 by 1. So, we have to take that expression, that is EMF of the cell without transference is equal to 2.303 RT by NF log A2 by A1. And we should note that here the students make a mistake in selecting the A1 and A2. We know that A1 should be greater than A2. Okay. When we come to an ideal condition, this expression can be written as 2.303 RT by NF log concentration of, that is I am putting it as C2 divided by C1, because we consider the condition to be ideal, where the ideal condition is activity is equal to activity coefficient into molality. Here the activity coefficient value is equal to 1, that is the ideal condition. So, activities are directly equal to their concentrations. So, I am putting it as C2 by C1. Okay. Again, here also we will have to mention that C2 should be greater than C1. Now, while choosing the concentration, they have just told that we are having 2 silver electrodes, one immersed in silver nitrate solution of concentration 1 molar, the other one in 0.01 molar. So, which should be taken as C1 and which should be taken as C2? Okay. So, if we consider the activities, okay, you can put it as activities also, because gamma is equal to 1, A1 or C1, whatever you consider, should be equal to 0.01, because we know that C2 should be greater. That means A2 or C2 should be the 1 molar one, and this should be 0.01 molar. Hope it is clear. Temperature is 298 Kelvin, and we know that silver on oxidation and reduction, the value of number of electrons will be 1. So, N is equal to 1, and now E without transference substituting. Since the temperature is 298, I can put it as 0.0591 divided by N, that is 1, log C2 should be greater than C1, that is 1 by 0.01, and on solving you will get the answer as 0.1182 volts. Okay. Here also you take 0.0591 in the scientific calculator, press log, give in brackets 1 by 0.01. The answer will be 0.1182. Now, to conclude, in this session we have been seeing electrolyte concentration cells without transference, and in without transference we have been seeing cells constituting of electrodes reversible with respect to cations and reversible with respect to anions, and the Nernst expressions are given as E without transference is equal to 2.303 RT by NF log A2 by A1 for those with cations, and here A2 should be greater than A1, only then E without transference will be positive. Now, in terms of molality, it is equal to 2.303 RT by NF log gamma 2 M2 divided by gamma 1 M. E without transference in terms of mean ionic activities, it is equal to 2.303 RT by NF log mean ionic activity of 2 divided by mean ionic activity of 1. Next is cells reversible with respect to anions. In that case, it is again the EMF of the cell will be equal to 2.303 RT by F, there is a missing of N, NF log A1 by A2. Here A1 should be greater than A2 with respect to anions. With respect to cations, it is a reverse case. And again in terms of molality, it is equal to 2.303 RT by NF log gamma 1 M1 divided by gamma 2 M2, where gammas represent the activity coefficients, and E without transference in terms of mean ionic activities is equal to 2.303 RT by NF log A plus or minus 1 divided by mean ionic activity of 2. So, with this we finish this session. Thank you.